So I'll be discussing about 24/7 energy through renewable energy and leading to energy security. Quickly jump into. Okay, so setting the context. Essentially, there is urgency for sustainability in India. People have talked about the world over issues, and in India, of course, it's no different. In a city like Delhi, if you are there for a day, you are smoking 10 cigarettes. A number of people are dying because of pollution. Millions are displaced due to changing rainfalls and other patterns. So, as was rightly mentioned by the earlier speaker, that it's the climate change is here. There's no discussion on that, and how are we going to mitigate the climate change is something that we need to really look at. And renewable energy is one of the ways in which that can happen. We require energy for everything. We require fuels for domestic heating and commercial establishment industries, fuel for transportation and commercial entities and commercial institutions. We require electricity for lighting and other applications, and the list goes on. So we are definitely dependent on energy, and that is something that we cannot run away from. And when we use energy, we get into the aspects of pollution. So when I'm talking about renewable energy, I would always look at the emissions as one of the most important factors. Also, when we look at energy, we have to look at sustainability of the energy sources and sustainability of the country as such when using that energy. Typically, I would always say that there are 5 aspects that one has to look at when solving any issues or any problems. And those aspects are on the left-hand side. We have to look at food, waste, water, health, and energy in a holistic way. That's the only way we would be able to solve a problem. Otherwise, we start looking at one and we start creating problems in the other. I mean, the classic examples, I can give a number of examples, but we solved our food problem by getting into green revolution, and then we created a problem with the land by putting more and more fertilizers in the land, and then reducing the overall organic carbon from the land, releasing all that carbon out, and that is also adding to the emissions today. We have tremendous problem with waste, and I don't have to go into details of that. Essentially, if you look at on the right-hand side, we have a number of resources. We have land, minerals, water, biomass, and everything. But whatever we want to do, we need energy. Any conversion, any use that we want to do for any of these resources, we require energy. And when we are looking at energy, we are also looking at emissions. Hence, we getting into the new paradigm have to look at a number of shifts in paradigms. One is, we have been talking about growth. I think we should be looking at development rather than growth and focus on that. Then we are looking at energy efficiency most of the times, but I think the first step would be to reduce the demand for energy. We are looking at fuels. We should always be looking at renewable energy as part of the fuels. Then everybody talks about upfront cost. We should be looking at life cycle carbon footprint rather than upfront cost. Waste management is something that we are looking at, but I think first thing to do is reduce the waste. Waste reduction is what we should be looking at. We are talking about consumption, we should be really talking about conservation. And then linear economy to circular economy. And I think the most important aspect in the whole thing is we are looking at large energy grids. Instead of that, we should be looking at a network of small microgrids. And that's the future of energy. So when we start understanding energy, we have to also look at emissions. And here's a quick look at where we stand. Siddharth talked about scope 1, scope 2, scope 3 emissions. There is a pictorial representation of that. Essentially, scope 1 is going to be what you burn in the zone that you are looking at. He talked about Pune metropolitan region. So whatever you are burning in the Pune metropolitan region actually emits directly in the region. Even the solid waste that we generate adds to the waste in the Pune metropolitan region. Of course, the vehicles add to that and so on and so forth. But I think most importantly, the scope 2, which was like 42% of the total emissions, is something that we should be looking at, because that is coming from electricity, which is not getting produced in the area where you are looking at the emissions. And this is a very important aspect, looking at the total energy scenario of the country. And of course, scope 3 emissions are something which are happening outside of the zone that you are looking at, but they are happening because of the consumption that you are doing in that zone. So may it be food, may it be transportation going from, traveling outside your zone, and so on and so forth. So quickly looking at what is happening inside your zone, or what is happening in terms of emissions when you consume some fuel. This is a table that I would want to quickly explain. Any fuel that you use typically is associated with emissions. So the first column gives the fuel, or the last entry in that is electricity. I'll quickly talk about that as well. But when you're using diesel, if you use 1 ton of diesel, it actually emits 3.14 tons of carbon dioxide. Now, if you are using gasoline, there is some other number. CNG is 2.75, coal is 1.51. But the last entry is the electricity that you are using. Actually, every megawatt hour of electricity that we use is leading to 0.82 tons of carbon dioxide emission. And of course, you can look at the calorific value of fuel and how much work that burning of that particular fuel will give you if that entire energy was to be converted in the work. And work here, I'm looking at kilowatt hours per kg of that work at 100% efficiency. And the numbers are great, but that's not the reality. That is not what is happening. Now, if you look at this table, it's a table on 2 pages. I'll quickly explain what this is. It's a very busy table. What you are actually looking here is the different fuels in the first column. And then we have different applications that we use the fuel for. Then the third column gives you the typical efficiencies in which these applications are there. And then in kg, if I were to produce an output of 1000 kilowatt hours, that is 1 megawatt hour from this particular fuel at this particular efficiency, how much fuel will I consume? And if I know the fuel I'm consuming, then I can actually come back and calculate based on my earlier table as to how much I'm going to emit. I'm putting this table in the perspective because I would want each of you to understand that if we want to do some work, say if I want to take an elevator from ground floor to 10th floor, then the work done is same whether I'm using electricity for taking the elevator up, or I'm using a diesel engine for taking the elevator up, or I'm using gasoline engine or whatever, even steam I'm using, the work done is same. So how do we compare everything? I think the best way to compare is to look at the output work that we want and see what input we have to give, and then work out the emissions for that particular input. Having said that, this table actually then goes into gasoline for transportation, then CNG for transportation and other applications, then LPG for heating and cooking. And the next part of the table talks about coal for various applications, kerosene for various applications, and then electricity itself for different applications, say transportation, heating, then probably doing hot plate or induction or whatever, we are using it for cooking. Now, if you look at transportation as one example, because I would really want to drive this point home, that if you are looking at transportation as an example for use of electricity, then the efficiency is very high. You can have 85% conversion. And then if you say that I'm going to use electricity to produce 1 megawatt hour of output, then how much input do I need? That gives you about 1.1 megawatt hour or 1.17 megawatt hours of input. And that leads to about 0.96 tons of emissions of carbon dioxide. Now I'll go back to the earlier part of the table and start looking at if I use diesel for transportation, what is happening? Diesel for transportation is giving 30% efficiency, and I use about 360 or 368 kg of diesel, which gives me an emission of 0.84. Now, mind well, I'm looking at the same output, same work done. Now, if I use gasoline for that, then my emissions are 0.78. And if I use CNG for that, my emissions are 0.57. So all of us are looking at electricity to be the least polluting input for transportation. But what this table is telling us is that for the same output, if we are using electricity for transportation, electricity is the maximum polluting entity. Now, this is completely counterintuitive, but I think it is very important for us to understand that there are two different aspects. One is energy efficiency and other one is emissions. And if we are looking at carbon neutrality, I think emissions take priority over anything else. And that is something that we have to keep in mind going forward. So what are the solutions for that? And what are the sustainable solutions, and what are the solutions those are going to be giving us kind of energy security? Of course, first and most important thing is, as I said, it is efficiency for resource use. So we have to make sure that we don't consume too many resources. We have to look at energy efficiency, because renewable energy or anything else comes later. First is you reduce your consumption, and this table gives various measures one can take for domestic industrial transport, and I'm not going to go into details of that, but energy efficiency is number one. When we are looking at energy, we can look at energy and matter, and they are interconvertible. On Earth, if we are producing energy by using matter, then we have to remember that matter is finite. And we have to avoid doing that. I mean, there are a number of ways. I mean, there is gas, there are solids, there are liquids, you can burn them. Even nuclear energy is there, but all of them are finite resources. Fortunately for us on Earth, we have an infinite source of energy, which is coming from outside of Earth, and that is sun. And so we should be finding ways and means of harnessing sun. Of course, solar photovoltaic, solar thermal is there, wind, hydro, bio are all the ways and means of harnessing the sun. What happens in India? Do we have enough sun? Do we have enough potential? And fortunately for us, India has got excellent potential being a tropical country. We have 3.28 million square kilometers. Our average solar radiation per square meter on Indian soil or on Indian ground is 5.5 kilowatt hours per square meter. Now, if you look at this number, it is about 7.5 times of total annual energy consumption of India coming to us in a day. So I don't think there is any doubt that we have enough energy available. It's a question of how do we use it. Do we have sufficient rainfall? Yes, we do. I mean, 1.05 meters is the total average rainfall on the entire area of India. That is enough water to give 2 crop cycles and probably have more for the third crop cycle, and enough to drink and enough to keep for the next year if there is partial drought. So it's a question of managing. We have large cultivable land that we can use. Wind potential, of course, every year the wind potential is keeping on increasing because the technology is improving, and we have got about 300 gigawatts of wind potential at 100-meter mast height and 700 gigawatt when it goes to 120-meter mast height. Bioenergy, of course, we have very large potential of 42 gigawatts with excess biomass that we have. And most important thing about India, we were talking about economics, we were talking about funding. We have a very large population. That means we have in-house large market. We are 20% of the world. We have economy of scale. So we should not be, looking at funding from outside. We should be looking at funding from within. So we have solar photovoltaic, solar thermal, hydro, wind energy, and bioenergy. What happens? Are these really green? Is something that we need to ask ourselves. Do they pay for their own emissions? And if you look at solar photovoltaic, it pays for its own emissions in less than 2 years. And bioenergy, if you take an example, it has got a life of 15 to 20 years, and it pays for itself in less than 2 years. So essentially, if you really want to go green, the first step that we need to do is focus on the core sectors going green. and that is imperative. So your embodied energy and embodied emissions are green. Once that happens, I think we have started walking the path. And the economics,
wind up in a minute. Sorry, but if you could wind up in a minute or two.
Yeah. So the economics of renewable energy is definitely there. There's no doubt about that. I'll just quickly pass through that. I just want to spend a minute here. When I said that the solar photovoltaic pays for itself, this is an example of 100 kilowatt solar photovoltaic system. If you look at the life cycle emissions of that system, and if you look at the life cycle emission reduction from that system, it reduces about 2,604 tons of CO2 over life. And it actually, if you reduce the emissions that you can attribute over the life cycle, the net positive is 2,150 tons almost. It is only 8.3% of its service life. Now, if you look at similar example for biogas, biogas has got very interesting advantage because it is using waste and it is converting that to not only biogas, but it also is converting to fertilizer. So you have a number of ways in which you are actually saving emissions. And the emission saving for a typical 6.4 ton CNG plant based on bio-CNG, the emissions that it does in the life cycle can be recovered in about 2.6% of the life of the biogas plant. So that is something which is very interesting. So we have energy source selection. I just want to quickly go over that. There are different applications: lighting, other electrical applications, heating, cooling, and moving. And here is a quick algorithm which we can probably use. If you have lighting, go for daylight. Then if not, go for renewable electricity. If not, then go for battery. The worst is grid electricity. Now, if you have got other applications of electricity, then first is, of course, go for renewable energy. If not, go for generator, your biofuel or CNG, LPG, diesel. Then you go to grid, because today grid is rather largely polluting. Then if you have heating and cooling application, go with the waste heat. Then go to renewable in terms of solar. Then otherwise go to burning fuels. Then go to electric grid, and then go to renewable electricity. And then the last one is moving, that is prime mover kind of application. Today's scenario, it turns out that engines are the best. Then you can go to renewable electricity, then battery backup, and last goes the grid. Now, this is something that will keep on changing as we improve our electricity generation and reduce the emissions in our conventional electricity generation. Most important thing is the core sectors have to go from conventional to renewable and least polluting things. So in a nutshell, if I were to walk a path for energy security, first I should start with 100% measurement of electricity, water, fuel, and other resources, and then drive the reduction using policies, regulations, act, incentives, and penalties. Then go to reduced consumptions of the same. And for that, I need to do awareness building, behavioral changes, pledges, the economics, and so on and so forth. Then I have to go to alternative sources. This is a third step. So renewable and sustainable, and we need to look at life cycle emissions, life cycle costs, economics. It is important because it's local, it is hybrid and smart governance. Then last is the evaluation that we want to do in terms of whatever we have done. Look at the per capita emissions, air quality, water quality, and so on and so forth. And then we have to look at the economics. Most importantly, look at energy, health, food, water, waste as a collective entity, and then equitable availability. Most important thing is renewable energy is decentralized, it is local. So there is autonomy at local level, and that leads to energy security. And it is a sustainable, it will increase our sustainable development index. Today, India is 120th on the list of 165 countries. And if we do all that, we will end up developing a network of smart microgrids for a sustainable, sustainable alternatives for a energy secured and sustainable future of the country. Thank you so much.